Hey guys, what's up and welcome to another RMA Fire tutorial. Guys, we're gonna be creating this cool chocolate simulation. It's gonna be a quick way of creating it. I wanna kind of like get you guys up and running as quick as I can. So without further ado, let's open up Houdini, and you will notice that on my file I created this strawberry asset that you can use, and it is non-commercial. Just so you guys know. Let's drop down a file in Houdini and let's just come here on the assets, hit strawberries, OBJ, and our OBJ asset. Now let's hit transform and make it a 0.01 so that move century to origin and make this a 0.01 and drop down a box so that we can have an idea what the size is. So let's see, 0.05 maybe. All right, so this is okay to play with. Place it in a decent way, like something like that. And let's do a UV quick shade. Drop that here. And let's see what we have on our ship, on strawberry, and on our maps. And we're gonna load our base strawberry color. All right, so we have this, we have a strawberry, and we're basically done, guys. Just kidding. All right, so we need a ground, so let's drop down a grid. Damn, I can't fucking type today. All right, so we have a grid and we're gonna merge them together. All right, so that's our base, and now we want an emitter to like drop down the chocolate. So we're gonna do a box, and let's have a look at our box. Let's drop down the transform. We want this box to be kind of 0.5 its scale. And now what I want to do is actually make my strawberry 0.8. So I'm going to cheat so that like sometimes small scale liquids are harder to do than something a little larger. So working with bigger scale in some fluid sims, it can be a little bit easier. So these ones are scale transform. Then we're going to drop another transform and have this one rotate this. Let's see, this. Let's just rotate it to do something like this. Drop another transform, and this one can rotate $F here. Hit this real-time button, and now it's gonna be rotating like this. And let me see what kind of motion we want this to do. So maybe we do something like another transform here and offset it like this. Then another transform, and this one is going to basically rotate like this. So let's do another $F right here. Yeah, let's see what we have. So something like this is cool because yeah, that's gonna be kind of like our source. And I kind of wanted to do a $F on the Y as well, so that it's like going up, but times 0.01, so way slower. Dollar, damn. $F times 0.01. And let's have this rotate a little quicker in this point. Multiply by 0.5. by 2. So yeah, something like that is kind of cool. So let's do a flip source. That's gonna be our base source. I want this to start a bit higher. Already, and let's do a dubnet. Gonna drop down a null and name this out source. Sorry guys, I'm typing horrible today, mainly because I'm trying to have the mic close to me so that it sounds a little better, but sometimes it just like throws me off. So let's do a flip solver, and we need a flip object, and we need a volume source. On our flip object, we want to delete this, and we want to connect this one here, and then this one is where we're gonna say that we want to import our source, and we want this to be flip source flip, and we want to come here and say that our actually in the flip object and the guides and the particles, and you want to visualize this as particles. We're almost there. And then on our flip object, we want to increase this resolution, say 0.05. All right guys, so one little mistake that I did, we want to copy particle separation and paste the relative reference here to the particle separation, not to the voxel size. That should now give us all the point information that we need for the sim. So now we got that working. Now what we need to do is we're going to make a collider out of this. So extrude volume onto our grid so that it is a solid volume, something like that. And now we want to do a collision source, connect this here, and then we're gonna drop down a null, and we're gonna do out collide, and then the second one's our collider VDV, because the second one basically just creates a VDV representation of what we are going to, what we are simming. So let's drop down a gravity and drop down a merge and a static object, and make sure that the static object is on the left side. On our static object, we are going to say collider, and then on our collisions, we are going to select proxy volume here and say collider VDV. So if we select our collider and we basically just look at it here, we can turn off the display and turn on the collisions, and you will see that it's pretty low uniform divisions. So let's say 55, 111 for 101, and that's fine with me. Sorry, display. We have this, and let's hit play. Let's see what we get. So we got a raw, very not great looking sim. And basically what we just need to have like a lot more viscosity. So let's go ahead and select our flip solver, and on our particles we want to add an attribute age ID, and we want to volume motion and viscosity and enable it, and let's say enable viscosity by attribute, and let's make this 50. That's not really changing much, and that's because we gotta make sure that our viscosity is also enabled here in our initialized velocity. Add viscosity attribute, and let's see, on our surface, our physical tab, we want our viscosity to be 100. And that's already working. You can see that there's definitely some viscosity happening now. So in theory, you don't have to really enable it on the flip object for now, mainly because we're not really using an attribute to drive the viscosity on this sim. It's actually a little bit simple right now, but we can look into that on the very shortly, or on part 2, because I don't want to make this video like ultra long. So yeah, this is basically what this first part gives us. And what I want to do, just to show you guys a little better, is just tweak these values here a little bit. So like maybe our values there are a little quicker. Let's have a look at what this gives us. And that's gonna look better because it's obviously going to overlap with the chocolate that we've already poured on top. So let me just wait for this flip book to roll and I'll show you guys what it looks like. All right, guys, so I'm back, and basically this is what the flip book is looking like. So I think that, for example, for usually if you want to do just like chocolate dropping on top of something, this is an okay start, but we definitely need like more control as to, for example, like the best control that you want to have is like as it pours, it kind of increases the viscosity dramatically so that it kind of like becomes like more how do I say, like for example, it's hot here and when it falls it becomes more viscous, so it's more dense, more viscous. So I can show you guys real quick how we can set that up, and that's gonna dramatically change the results that we're getting. All right, guys, so let's get that set up. Let's set up how we can control the viscosity as it's falling down. So let's do a pop bop, connect this into a second input geometry, coming here, and what we're gonna do is we're gonna do a ramp, a fit range, and we wanna grab our age and we wanna fit our age between two values. So we want our original age to be between a 0 and 1 value, so clamping all of our timeline between 0 and 1, and control it between 0 and 10. I mean between the 1 and 10. So we're controlling our age between 1 and 10 right now. Then we're gonna ramp the velocity in which the viscosity is going to be increased by time. So we're gonna set this to a spline ramp so that it's not with color. And then we're gonna do one final fit range to fit the value of the intensity in which we're going to ramp the viscosity. So how much viscosity do we want? From what value to what value? And between the age range we have created. So we want something between these two values, and we want to control that. We want to middle click and promote this parameter so that we can control them outside. And then we're gonna do a bind export, and this is gonna be our viscosity. So right here we are going to control the ramp that we created on the inside, and the minimum is 0, but we're gonna want that to be like, for example, start with 10 in viscosity and go into like a really high value. Let's have a look to see what we get. So you can see that right now it is becoming super high, the value extremely fast in time. So we're gonna want to have maybe 100, between 1 and 100. Let's see what we get. Which is still quite a bit of a very high value, but we're gonna tweak that in a little bit. So let's drop this down, and let's do something like this. And like right now is about finding our sweet spot of what's gonna work best for the sim. I think that's already looking way better. We can also come back into our VOP and fit this between 30. Between 1 and 30, so it's gonna be kind of like a longer time frame for it to like get solidified. And I'm gonna reduce my viscosity scale and start lowering that down. And that's definitely improving. Probably gonna reduce it even more. I mean, another thing is that our emitter is pretty fat, like pretty thick. But look at that. It's definitely more dialed in. So you can see that with your viscosity scale here, you can dramatically, like, it's kind of like a multiplier of what our viscosity is doing. So I think that's cool, but I wanna do 100, and I do wanna reduce this again to say 22. Let's see what we get. Okay, so you can see that like we're starting to get those moments that I really wanted to get, where like you get chocolate that kind of like oozes over each other like that, which is like super cool. But let's just crank that up a bit more. So let's multiply our scale by 10, and let's also come into our emitter and make it like half the size, and let's see what this gives us. You know, like another thing that really changes it a lot is like the shape of your emitter and the way that it looks. The speed and the size makes a dramatic change. It's pretty crazy how much it changes it. So it kind of depends on what look you're going for. I've gone as far as create like cookie dough type emitters on top, and that way you get a more realistic look when the client wanted in that specific situation. The client wanted sort of like a star shape coming out, so I was creating like a boolean to kind of like place it as a collider at the beginning of the emitter so that it would create that sort of like cookie dough type thing that you see often. But you can definitely start to see the results of the viscosity going on top of each other like that, which is kind of what I was hoping to get, like something that feels like chocolate, but it's also kind of could be yeah, like a viscous kind of liquidy thing that you do on food. So I definitely feel like that's looking way nicer. What I want to do now is we can do a few different things, and one of those things is play with the surface tension that is going to force some of it to like stick together a little longer. And then the other thing that I want to do is maybe see if we just let it roll a low viscosity for a good amount of time, and then it's just gonna start to ramp up into like a higher viscosity. So maybe something like that. And then we could do like maybe start this a little higher, and the rotation here I'm gonna increase to 10. And then I wanna start to break up the forces that I have in here. So first thing we're gonna do is drop down a trail stop to calculate all of the velocities. So compute the velocities here. And then you will see that that's basically just going to compute the speed in which our emitter is moving. So obviously this might be too much. So yeah, it doesn't seem to be liking this attribute, this trail right there. But let's do an attribute VOP, and let's come in here and do a turbulent noise. Here like that, and then I'm going to increase this and increase the frequency like that, and then I'm gonna do a bind export and this is gonna be my XD. And then on my flip source, I wanted to output fog, so that outputs like particles. And then right here, I'm gonna do a pop, drag, and then I want to do an air resist is equal to fit01 rand at ptnum 0.5 multiplied by xt. And this is just going to add an additional layer of random drag based on that noise that we created outside. And you can see it there already. And that's going to help like really break up the way the liquid starts to look. And something that I actually really like to do is crank that high, really high, or like even then multiplying my viscosity by a noise attribute like this. So let's just see what happens if we come in here and we do a bind, and we're gonna do XD, and then we're gonna multiply this here. So that noise is also going to multiply our viscosity. And what that's gonna do is like it's really going to create some like beautiful oozing, because a lot of areas here are gonna become like, yeah, higher viscosities. So you can see how some of these ones start to pile up. And break it up. You can see it here. See those ridges? And then once you guys upres this, boom, you begin to get some like super crazy detail in there. And we can even texture it based on those values. All right, guys. I hope that you guys like the way this is looking, the control that I've taught you guys throughout this tutorial. I'm gonna cut it off right here, and I'm gonna do a part 2 where we can go into texturing this and mix colors based on the attributes that we've created.